So you already wrote down these strategies from last time on page 620. We're going to learn what do these mean. Because our main strategies that we've had so far that we've already done. You've already changed things to sine and cos. That was one of the main strategies we learned in the first little bit. We've already combined fractions by getting a common denominator and getting a single fraction. We've talked a little bit about this when we did that one where we had tan on one side and cotangent on the other. So being aware of the other side, saying, hey, I can change both sides to tangent, maybe that will help me solve this, is a strategy that's important. To always be aware of what you're trying to get, what your goal is on the other side of that line. Okay? Ones that we haven't seen a lot of yet are the Pythagorean identities, and we're going to learn those this morning. We haven't seen multiplying by the conjugate or build the other side. And with the Pythagorean identities, what to do when you see a 1. And finally, there's going to be ones where we need to factor. In fact, if you want to put a star beside build the other side and factor, sometimes you're going to use your main strategies, these green ones that we had here, changing things to sine and cos and writing both sides as a single fraction. And at the end of that, your proof isn't done. That was like that question I gave you the other day where I just said, change both sides to sine and cos and simplify both sides as a single fraction. And when we were done, they didn't match. So what do we do when they don't match? We're going to have to use one of those two strategies, either factor or what I'm going to call build the other side. And I'll explain the build the other side a little bit more in depth in a minute. So, what are our Pythagorean identities? Well, we already know the one big idea, and this is on page 622. We already know that sine squared plus cos squared is equal to 1. Here, there they are. These are our Pythagorean identities right here. Sine squared plus cos squared equals 1 was one of our big ideas. Well, if we take sine squared plus cos squared equals 1 and we divide everything by sine squared, or everything by cos squared, watch what happens. So if I have sine squared plus cos squared equals 1, and I divide everything by cos squared, well, sine over cos is tan. So sine squared over cos squared is tan squared. Cos squared over cos squared is 1. And 1 over cos is secant, so 1 over cos squared is secant squared. So this second one is just the same as the first one if you divided everything by cos squared. If you divided everything by sine squared, well, sine squared divided by sine squared is 1. Cos over sine is cotangent, so cos squared over sine squared would be cotangent squared. And 1 over sine squared is cosecant squared. Now, all three of these are on your formula sheet. So you'll have them and you'll have access to them. But again, for your identities, you'll want to have them memorized because you'll want to be able to recognize them easily. And if you don't have them memorized, you won't see them quick enough when you're doing an identity, and you might miss a shortcut or a way to make a proof quicker. Now, with all of these identities, you can do rearrangements of them. You've already done rearrangements of sine squared plus cos squared equals 1. On our review, you had to replace a sine squared with 1 minus cos squared. So we can rearrange these identities, and we know that sine squared is 1 minus cos squared, or cos squared is 1 minus sine squared. And you will use those a lot. So anytime you have a cos squared, you can replace it with a 1 minus sine squared. Or anytime you have a sine squared, you could replace it with a 1 minus cos squared. Similarly, you can play around with the other ones. So if you have tan squared plus 1, you could get tan squared by itself by subtracting 1 on both sides. Or you could get the 1 by itself by subtracting tan squared on both sides. And similarly with the last one, you can do a rearrangement to either get cotangent squared by itself or get the 1 by itself. So we add these to our toolbox. So far for proving, we've had our reciprocal functions. Tan is sine over cos, cotangent is cos over sine. Those have been the functions we've used so far. And a little bit, probably in some of the proofs, you've used sine squared plus cos squared equals 1. But now we can add these ones as well. So when we go back to our strategies, that's this new strategy. Use the Pythagorean identities. If you see a 1, or you see a tan squared, or a secant squared, or a cotangent squared, or a cosecant squared, you should think maybe one of these is going to help me. And it's going to help me build it quicker. Okay, so let's go to example 1. We'll do this one off to the side. For our first one, cotangent plus tangent equals cosecant secant. Watching you guys coming around, most of you chose, I'll draw the line here, chose the strategy of changing things to sine and cos. So cotangent is cos theta over sine theta. Tangent is sine theta over cos theta. And cosecant is 1 over sine theta. And secant is 1 over cos theta. Now, if you choose the strategy of changing things to sine and cos, then the next part of that strategy is writing both sides as a single fraction. The right-hand side, well, if you multiply those fractions, we've got 1 over sine theta cos theta. On the left-hand side, in order to add fractions, we're going to need a common denominator. So this one is missing a cos on the bottom, and this one is missing a sine on the bottom. If we do that, we've got a common denominator of sine theta times cos theta. And if I multiply on the top, cos times cos is cos squared theta. Sine times sine is sine squared theta. So we notice now that our denominators are the same. All we have to do is make our numerators the same. And here's where a Pythagorean identity comes in. What is sine squared plus cos squared? It's equal to 1. So you can change that. 1 over sine theta cos theta. Therefore, the left side is equal to the right side. So for that one, that is probably the easiest strategy to go about this one. And it's what I would recommend for solving this one. For the second one, this one I'm going to show you 2 different techniques, because coming around, I saw some people choose to change things to sine and cos, and I saw some people choose the idea of a Pythagorean identity as a way to make it shorter. So I'm going to start with the sine and cos way, because a number of you started with that, and it will work. It'll just be a little bit longer. So cotangent is cos over sine, so cotangent cubed will be cos cubed over sine cubed. Here, cotangent is cos over sine. And one thing I want you to look in your work is, are you remembering to include the variable every single time? If you forget theta once, it's an automatic half-mark deduction. So don't, even work off to the side. If you just want to write, if you go like this somewhere, you lose a half a mark. Because that doesn't make sense if there's no variable there. So they're very particular about that, so I want to point that out. Don't forget your variables. So I've got cos over sine. Cosecant is 1 over sine squared minus cos over sine. So when I multiply these ones, I have cos theta over sine cube theta. I'm subtracting another fraction, so again, my strategy of getting a single fraction, how would I get a common denominator? This one needs to multiply top and bottom by sine squared. So now I have a common denominator. I could, in fact, subtract those fractions. Could have probably done that all in one step here. And you get cos theta minus cos theta sine squared over sine cubed. Again, I'm always thinking about being aware of my other side. I notice my denominators are the same. Things are good that way. But my numerators are really different. How do I deal with that situation? Well, here I would think about some of those advanced strategies. If you get stuck, can you factor? And this is a good example of where factoring comes in. On the top, there's two terms, and there's a cos theta in common in both of those terms. So you could factor that out, leaving you with 1 minus sine squared inside. And again, you have to have your Pythagorean identities memorized and all of the different rearrangements of them memorized. What is 1 minus sine squared equal to? It's equal to cos squared. And so this is going to equal cos times cos squared, which will give you cos cubed over sine cubed. And so changing to sine and cos, we had to use the factoring strategy. So this is why I wanted to show this, because it comes out as an important strategy that we would have to use once we got to that step. Now, this isn't the shortest proof for this one. I'm going to erase it now. Go back to the beginning, redraw my line. And knowing my Pythagorean identities and knowing that there's a relationship between cotangent and cosecant squared, cotangent squared and cosecant squared, and also being aware that could I do something here so that my left side and my right side were all in the same trig function? Well, I can change cosecant squared because I have an identity that cosecant squared is cotangent squared plus 1. So if I do that, now both my left side and my right side are in cotangent only. That's going to be nice because maybe if I simplify it, it's going to be the same. Well, what can I do with this? I can distribute. That'll give me cotangent cube theta plus cotangent theta minus cotangent theta, which is just cotangent cubed. So it's with practice that we start to see these other strategies come up. And sometimes you'll do a proof and you'll say, okay, I just got that proof, I changed it to sine and cos. Then you might want to go back to that same proof that you just did and ask yourself, can I see a different way to do this? Can I see a shorter way, or can I see a longer way? You know, obviously, over time, you would like to be the shortest possible, but that might not always happen. But by finding different techniques, you'll see different strategies come up. Yes?
In tests or quizzes, are you going to ask us to do it in a specific way?
No. You will always get prove, and then it's up to you. And if it takes you 8 pages, it takes you 8 pages. There's none that should take 8 pages, but sometimes people go in circles for a while. Like you do something, and then you factor it and undo it, and then do it up again, get a common denominator, then unget a common denominator. And you can go in circles for a very long time and not make a mistake, but just take a long time to prove it. But no, there isn't, you have to do this one in the shortest way possible. So here's our third one. This one was the hard one. So in this one, I can see someone being very tempted at the beginning to change things to sine and cos. Notice on the right-hand side of the equation, it is already in sine and cos, and it's already a single fraction. So let's say we started with that. I started with sine to the 4 theta over cos to the 4 theta minus 1 over cos to the 4 theta. I already have a common denominator, so now I can write this also as a single fraction. Whew. So I have a single fraction on the right, a single fraction on the left. Both are with sine and cos, but they are not the same. This is where I start those two things. And I start factoring, and I start build the other side. We haven't seen the build the other side strategy yet, and I'm not going to show that to you for a while. I want you to think about the factoring strategy. How can you factor? Can you factor the right side, or can you factor the left side? What do you notice? And in our strategies list, not only do we write factoring as a strategy, in brackets, to help you recognize something important for factoring, is listed difference of squares. So in that idea in particular, if we go back to this one, do you recognize that the top is a difference? There's a minus sign in between. And both the first term and that last term are squares, because 1 times 1 is 1. And what times what is sine to the 4? Sine squared times sine squared. So I can factor the top here to be sine squared theta plus 1, sine squared theta minus 1, all over cos to the 4. Okay. So how does that help me? Well, nothing matches up perfectly on the top either. The question is, can either one of these top factors be related to our Pythagorean identity here? How could I rearrange sine squared plus cos squared equals 1 either to look like this one or this one? And I'll write it off to the side here. Sine squared theta plus cos squared theta equals 1. Can you rearrange something in one of these to match up by rearranging that equation? Can I ever get sine squared plus 1 all by itself on one side of this? No. Can I ever get sine squared minus 1 all by itself? Yes. What would I have to do? The 1 would have to come over, the cos would have to go over there. So it would be negative cos squared. So now I can rewrite this as sine squared theta plus 1, and this as negative cos squared theta over cos to the 4. This is a single factor. This is a single factor. These two are going to cancel out with 2 on the bottom. And we're just left with a negative 1 there. If you distribute that negative 1, you'll get negative sine squared minus 1 all over cos squared theta. And we'd be all finished. So that was changing things to sine and cos. As far as making it even quicker, you might have noticed right at the beginning it's a difference of squares. So you could have factored that tan to the 4 minus secant to the 4 as tan squared plus secant squared, tan squared minus secant squared. And tan squared minus secant squared is a rearrangement of this, and it's equal to minus 1. And that would also help you solve this a lot quicker.